Hello, calculus. Limits can be represented in multiple ways, including graphically, tabularly, and analytically. In today's video, we're going to learn how to estimate limit values from graphs. Let's get started with an example. So here I have a graph of a piecewise defined function f of x, and I'm asked to use the graph to estimate the limits below. The first limit reads the limit as x approaches 2 from the right of f of x. And I know it's from the right because of this little plus sign up in the exponent of that 2. So the first step would be to find the value which you're approaching. In this case, it's 2. And the next step is to make sure you're coming from the correct direction. In this case, since we're coming from the right, that means we're coming from the positive infinity side of the x-axis and working our way towards positive 2. So the trick about finding limits graphically is to follow your function from either the right or left or both sides and ask yourself, as I'm getting closer and closer to 2 with my x values, what y value is my function getting closer and closer to? So starting from the right-hand side, I'm following my function here until I get to just about 2. And if I ask myself what y value I'm getting closer to, I can see that I'm actually getting closer to the y value of 6, which means that my right-hand limit as I'm approaching 2 of f of x is equal to 6. So moving on now to the second limit, it reads the limit as x approaches 2 from the left of f of x equals. So I know it's from the left because of the small negative sign up in the exponent. And what it means to come from the left is to come from the negative infinity direction and work your way towards positive 2. So again, the trick is to find your function and follow your function along from the left side this time and ask yourself, as I'm getting closer to my x value of 2, what y value is my function approaching? And here we can see that our function is approaching the y value of 6 as well. So this is a super important key note about limits is if your right hand limit and your left hand limit are equal to the same value, in this case, both of them are equal to 6, that means your general limit is also going to be equal to that value, in this case, 6. So because my right hand limit as I'm approaching 2 is equal to 6, and my left hand limit as I'm approaching 2 is equal to 6, my general limit as x approaches 2 is also equal to 6. If there's no plus or minus in the exponent of your approached x value, that means we're talking about as we approach x from both directions, what y value we are approaching. And in this case, since both the right and left direction are approaching the y value of 6, we know that our general limit as x approaches 2 is equal to 6. So let's move on to another example. So here in this example, I still have the same piecewise defined function f of x, and I'm again asked to use the graph to estimate the limits below. The first limit reads the limit as x approaches 6 from the right of f of x. So my first step is to find my approached x value. In this case, it is 6, so it'll be here. And to make sure I'm approaching from the correct direction. Since there's a small positive, that means I'm coming from the positive infinity side and working my way towards 6. So I'm coming from the right-hand side. So the trick again is to find your function and follow along your function and bring your x values closer and closer to your approach x value, in this case 6. And ask yourself, as I'm getting closer to 6 with my x values, what y value is my function approaching? In this case, it looks like we're approaching the y value of 7. So that means that the right-hand limit as we're approaching 6 of this function f of x is equal to 7. Moving on to the next limit, we have the limit as x approaches 6 from the left of f of x. So same process, except for this time, since we do have that small negative, that means we're working our way from the negative infinity side of the x-axis and going towards our value of 6. So coming from the left-hand side now, I just follow my function along, and I ask myself as I get closer to 6, what y value am I getting closer to? In this case, it looks like I'm approaching the y value of 4. So this means my left-hand limit as I'm approaching 6 is equal to 4. And this brings us to another key stamp when it comes to graphical limits, and that is if your right-hand limit and your left-hand limit are not equal to each other, then that means the general limit as x approaches 6 does not exist. And we denote that by writing DNE for does not exist, right? Notice how I did cross out my equal sign um, because it's not equal to does not exist, it just does not exist.